audio signal. Okay, and it's basically giving out waves. And then let's say you basically are having a sound which would be, let's say, a wave which will have certain wave, let's say x angstrom, right? Maybe the wavelength. And then what you have is basically a sine wave, something like this. And then you have got another source of sound which actually gives you a wavelength, let's say is y angstrom. So you have another sound wave, okay, and this time it may be the longer wavelength and so on. So in this way, what you can have is these wavelengths which are actually all you can determine them individually. But then if you basically have a sound source which is actually emitting all kinds of frequencies, all kinds of possible frequencies, then what happens is you are going to combine them, all of them, and you are going to get a resultant of this. So the resultant that you get, it's not that all of them are coherent, so it's not that you will be having interference which is always constructive. There will be destructive interference, constructive interference, and so on, a mix of both and so on. Okay, so finally the signal that you are going to get is not going to be as pretty as this. You might be having some kind of. Okay, now the problem is I cannot differentiate the signals here. I cannot really say that what are the frequencies that are involved here. So in order to just separate this out into its corresponding component, the mathematical tool that can be actually used, which is actually the best, is the Fourier transform. And that is why we need to study Fourier transform. So we are just not going to look into the application part of it as yet. Right now we are going to look into the mathematical description of the Fourier transform. Okay, so that's important. So let's begin. Okay, let's start with the Fourier transform here. So we have already introduced ourselves with the Fourier series, right? And when we actually talk about the Fourier series, what we do is we say that there is a limit to it, minus L to plus L, let's say, okay, or maybe minus pi to plus pi and so on. But what will happen if we are actually going to have it from minus infinity to plus infinity? So the thing is, what's going to happen when we are actually having the limit from minus infinity to plus infinity? Okay. So when we actually talked about the Fourier series and we wrote down fx, we actually had terms which is, let's say, a naught by 2 plus summation of an, I can write it down and read it now, nx, okay, plus summation of bn, let's say, cos of nx. So these are all summation terms. That means whatever results or whatever form of the function that we are going to have are going to be more or less discrete in nature. But when we are considering the limit from minus infinity to plus infinity, that means we are considering infinite number of values, we are going to shift into the integration part, right? And that is what we are going to understand in this Fourier transform. And this is why Fourier transform is really important. Okay. So let's try to understand this now and try to derive a relation based on this. Okay. So we have it here, and this is the series that we have. And as I told you, if you basically have a function, let's say we have got phi1, phi2, and so on. Okay, you can actually write it down in the form of some constants multiplied by the function. Okay, phi I. Okay, and it goes n goes from minus infinity to plus infinity. Okay, we've got so many values there. But here we are just going to consider that. Okay, that part, and then we're just going to see that what happens in the transformation equation. So here, let's say I have got this. This actually can be written in the form of e n e to the power I n I x divided by n. Okay, in the case when we are actually considering, let's say, the limit from minus L to plus L. Okay, this is the case when we are considering the limit from minus to plus L. Remember that is for x. Okay, not for n. N is from minus infinity to plus infinity is correct. The limit of x. Okay. So we will basically have these kind of forms. Okay. And before we proceed on actually to the integration part or understand how we actually get the integration part, let's just write down few things which we already know. The first thing, it's e to the power I theta, which can be written as cos theta plus I sine theta, right? And then we have got e to the power minus of I theta to cos theta minus I sine theta. And then we can actually write down what is our sine theta in terms of e theta, e to the power theta, right? So sine theta will be nothing but we can do it will be e to the power I theta minus e to the power minus the theta divided by 2 times of I. Right? And then we have got cos theta. Cos theta is equal to e to the power I theta plus e to the power minus I theta divided by 3i. So we have this relation now, and this way what we can do is we can actually use it here and modify this. Okay, we will see that what the exact role here. So we're just writing it down in terms of theta. So we simply write it down as a naught divided by 2 plus and then summation over n. Okay, and then this is a n divided by 2i because we are taking this. Okay, and I'm going to write it down in terms of theta only. Later on we can change the variable. E to the power I theta minus the power minus I of theta plus summation of n is E n by 2i, and then this will be e to the power I theta e to the power minus of I. So we have this relation now, and we can just combine the three class together. So we can just simply write down as a naught divided by 2 plus summation n, and then I can take it to be a n by 2i plus take this e to the power I theta and e to the power I theta together. So this will be dn by 2i, and then this will be e to the power I then plus summation n, and then we can combine these two terms here. So it is minus of a n by 2i, and then this is a plus. So we put a plus here. E n by 2i e to the power minus of I. So we have this relation now, okay? And just like we can write down the summation of c n e to the power I x divided by n, okay? So similarly for this also we can write it down in that way, okay? So I think I can just write it down, say, and just do a small correction here. This is n x, okay? So it's just like I n x. I should not write down n here. It is not converted into that formula, okay? I'm just telling it in general. Maybe I won't use it today. Just writing down the general form. So in a similar way, for this also, what I can do is and write it down as n, and then this is cn, and then this is e to the power I. So that's it. So this theta that we are actually talking about, this theta actually can go from minus infinity to plus infinity.
Mhm.
Yeah.
So in the case of cos theta equals to e to the power I theta plus e to the power minus I theta divided by 2. Now, is
Mm-hmm.
there any I term in the denominator?
Have I not written it? This one? This one you are saying?
Yes, yes, sir. I will not be there, I think, because expand it
Mm-hmm.
and just look at this because I term is extra here in the denominator part. 2i
Yeah.
in the place
Yeah.
of
So sorry. Yeah. Yeah. Okay. Like this should not be there. Correct this. Yeah. Okay. So we have got it as this is I, and okay. So there won't be any kind of I there. Okay, so then we have to just do the adjustments here with the plus and the minus sign, and then we have to take an I square there. Okay. But anyway, we are not going to use this result. Okay, yeah. So if it is an by 2I, and so this would be n, it will be just 2, and with b it will be just 2, and with an it will be I. Yeah, right. Right. Correct. So we have got this Cn e to the power I theta, and theta actually can go from minus infinity to plus infinity, right? So what we are saying that this range that we have for the theta term is going to be minus infinity to plus infinity. Now if that happens, what happens is that the summation can easily be replaced with a integration sign, right? But before that, we have to find out what should be the form of this Cn, and we already know the technique to it. So let's just try to find out the form of this Cn. Okay. So we can then, if we just write down this, we can say that this fx, okay, is equal to, let's say I have changed the limit. Let's say Cn. We actually know this n by f divided by l. Here I'll take n by f by l. Let's say I've taken the limit from minus l to plus l. Okay, and I know that this is actually nothing but the form of Cn. Right? So this is something which we already know. And we also know that how to actually find out what is Cn. So we've seen this in the first class of Fourier series. This Cn can be found out in this way. Phi n f inner product divided by phi n f. Okay. So let's just try to find out what is my f and what is the function. Okay, you can easily do it. I've already done it a number of times. So phi n square is nothing but if you're considering this the limit from minus l to plus l. We are not saying minus into plus infinity. As soon as you do it, that means we are going into the Fourier transform. Okay. But right now this is limit, and this is one phi n, and in this case phi n is e to the power I n pi x divided by l. And if you take phi n square, that means you're taking the conjugate of this. So that means this will be e to the power minus n pi x divided by l. And if you multiply both of them, the powers will be 0, so it will be just 1, right? E to the power I n pi x by l into e to the power minus I n pi x by l. That's the meaning of pi square. That's 1, right? If it's just 1, I'll be just writing down it as 1 into dx. And let me just do it. X, which is l minus minus l, so it will be 2. So we have the value of phi n square, okay? Just generalizing it. And then in similar way, we can also find out the inner product phi n. So the inner product will be minus l plus l, and then this fx e to the power phi n by h. So this is my result here, okay? And then what I can do is I can actually divide one by the other, and okay. So I can take this, so I can know what is my fx now. And there should be a minus sign. Let's check it once. So we have got it as fx, and fx is equal to the summation of Cn. So we can just take it to the summation, and and just take it to minus infinity to plus infinity, and Cn is 2l. Okay. So it is if you just find out what is my Cn here, you want to find out what is my Cn. Cn is product of this divided by phi n square. So it is phi n square is 2l. So it will be 1 divided by 2l, and that is the integration of minus infinity to plus infinity fx e to the power I n pi x divided by L. This is the term that we have, right? So fx can be written in that way, f of x, and then e to the power I n by f divided by L into dx. Okay, and this is actually under equation sign. So let me just make this space here. Okay. This is under the integration sign here, and minus infinity to plus infinity, and then this is whole thing divided by 2l. And here we actually have a summation of n. Okay, so this summation is there, and then we have got the taking value of cn. Okay, and dx into, we have got this one into e to the power I n by x divided by n. So this is a term which is under summation, and this is the value of Cn that we have. Okay, so let's not get confused. Okay, it's important. So now the thing is, I have to make it a continuous function in the sense that you're basically going to have the value of, whatever is the variable power of e, which is actually the variable here. In this case, it's x. It should go from minus infinity to plus infinity. Okay, and if that happens, what we'll do is we'll actually get rid of this summation sign. So for that, let's just do certain replacements. Let's say let kn, okay, is equal to n pi by l. I'll just do it for convenience. N pi divided by l. We got n pi divided by l. We'll just replace it with kn. Okay, and if we want to find out a very small change in k, that means it's nothing but k to the power n plus 1 minus of kn. We can write it down as pi divided by l. If you understand this, we will take n plus 1 here, and then pi by l minus of n pi by l. So just cancel it out, pi by l, right? So this is there. So in that way, I can write down what is 1 by 2l also. So 1 by 2l would be nothing but delta k divided by 2 pi. So everything I'm writing it down in terms of k. So delta k by 2 pi. How? Because what is delta k? Delta k is pi by l. So replace it by pi by l. Okay. So this will be pi by l. Okay, just create. Okay. This is working. So delta k is pi by l. So this is pi by l into 1 by 2 pi is there. So 1 by 2 pi. Pi will get cancelled at 1 by 12. It's the same thing, right? So that is 1 by 12, and the written is delta k divided by 2 pi. So if we just replace it here, what we can do is we can simply write down f of x as summation, and just replace it later, minus infinity to plus infinity and values. Okay, and this should be nothing but delta k divided by 2 pi is 12. Delta k by 2 pi, I've written it that way. And then I'm going to take the integration. Okay, and nothing I made a mistake here. This limit is minus of the plus l. So I'm not going to add down infinity right now. It is minus l to plus l. Okay, so this is minus l to plus l. I'm going to keep it as a 2. E to the power I. Okay. Now what is my n? What is my n? Where is that? N pi by l. So n pi by l is nothing but x, right? So what I can do is select kn. So I can do it in this way. I can write it down as e to the power I, and then I can write down as kn into x into this also can be written as e to the power I. So this is the term that I have written finally. Okay, after this we some kind of modifications. Okay, and then what we do is we say the question now is that we are not saying that it will be anymore with L. Okay, within limit L, it will be at an infinite range. So that means now what happens is I'm going to take up this condition when L tends to infinity. Okay, this delta k will actually tend to 0. Which is kn is equal to pi n pi by l So this is pi by L. So when L tends to infinity, this delta K is actually tend to minus, right? So we know this, and we can say will be continuous. L tends to infinity, right? So it will basically be the entire function will become a continuous function because L and K are more or less connected, and this is actually a function of K. This is also a function of K, and this K tends to 0 and L tends to infinity. That means both of them are connected. We have already shown that means this K will also become a continuous function. Okay. When someone mute the mic, your mic is on, and it will become continuous function because we are increasing the limit from minus infinity plus infinity, and at the same point del K will go to 0. So when del K tends to 0, that means we are talking about a continuous function here. That means this K to the 1 and this delta K both will be a part of continuous function now. Okay, and this is n is equal to minus infinity to plus infinity. There is no more n here at all in terms of K now. So that means this summation sign that we have, we can actually convert it into an multiplication sign. Right? So that is what we're going to do in the next step. Okay. So in the next step, what we have is this fx is equal to. So you have it. You can see this is 1 by 2 pi. So I can write it down as 1 by root 2 pi into 1 by root 2 pi. Okay, that will be 1 by pi. So I'm just going to show you why I'm doing this. But anyway, let me just do it first. So I'll just write it down in this way. I will write it down as 1 divided by root over of 2 pi. Okay. Then I'm going to have it as minus infinity to plus infinity. Okay. It got converted that summation into an integration sign. Okay. And then again I have got the conversion of L from minus infinity to plus infinity. Okay. And then we have got 1 by root over of 2 pi, okay, into e to the power minus. Okay. Oh, shit. I think I made one mistake here. Now this function that we have, we can actually write it down in terms of e to the power minus I mx pi by n. Okay, it can be written in this form. Please check this. Sorry, I think I missed it out. Okay. Minus sign I missed out over here. Here I missed it out. Here I missed out a minus sign. Okay. So this should be minus. Sorry, this should be minus. This should be minus. Huh? So please note, this is the function we have. C n e to the power minus I n pi x divided by L. This is also minus. This is also minus. That does not harm this. So no, this is minus. The other one will be plus. It will become 1. Not a problem. Okay. So please make sure this is minus. This is minus and should be. Just take the conjugate effect. Okay. We have some numerical problems which we will be doing. Check that. So this can be written as e to the power minus I k x, okay, dx, and this is there. And then we also have the other term, which is actually e to the power I k x. And and then there was a delta k, then there was a delta k. But if it's a continuous function, this delta k will actually come to the integration sign, and the delta k actually can be written as dk. Okay? We're talking about a continuous function here. This would be e to the power I k x. Right? So this term that we actually have, okay, here is actually called the Fourier transform, right? Okay. And this make this minus. So this is also minus, right? Okay. This is minus. This is minus. No problem. Check it again. So this term that we actually have here is something which is actually written as f tilde x. F tilde x. Okay, and this is actually called the Fourier transform. This is actually called the Fourier transform. So what we do is we can write down this form as fx is equal to 1 divided by root over 2 pi integration of minus infinity to plus infinity, and this entire term I will just simply write it down as f delta x. In lot of books, you'll just try to see that this is actually the notation for Fourier transform. I A F or decay. Sorry. Okay, where f(x) is equal to integration of minus infinity to plus infinity f(x) e to the power minus I kx. Okay, so this is actually called the Fourier transform. So what is this f tilde? F tilde is actually nothing but the Fourier transform of fx. This is the Fourier transform of fx. So we're going to do some numericals where we'll see that how we can use these Fourier transform.